To meet the enormous demand for electricity, the quest for newer ways of generating electricity continues. Nuclear reactions are one of the most important sources used for generating electricity. At the end of this module, you will be able to define nuclear fission, describe a nuclear chain reaction, describe the parts and working of a nuclear power plant. To begin with the basics, we are familiar with the structure of an atom. But have you ever wondered how all the positively charged protons are packed together in such a tiny space as the nucleus of an atom? Logically speaking, since like charges repel, shouldn't the protons get repelled and get scattered away? Well, inside the nucleus, there is a very strong attractive force, several thousand times greater than gravity. Nuclear force far outweighs the repulsive electromagnetic force present between the protons. Nuclear force is a great source of energy that gets released when a nucleus is made or broken. Watch how a neutron strikes a heavy nucleus and splits it. Nuclear fission is a process in which the nucleus of an atom splits into two or more smaller nuclei with the emission of some byproduct particles and energy. A nuclear fission reaction may lead to a chain reaction. A nuclear chain reaction is a self-propagating reaction in which the particle that initiates the reaction is also a byproduct of the reaction. When allowed to go uncontrolled, a nuclear reaction can be hazardously explosive as in an atom bomb. A nuclear chain reaction releases several million times more energy per reaction than any chemical reaction. We are going to understand how a controlled chain reaction can be made to generate electricity in a nuclear power plant. Let us explore the major parts of the nuclear power plant. The dome-like structure you see here is the containment building made of strong reinforced steel and concrete. This airtight containment structure ensures safety by confining the entire radioactivity within itself. This houses the reactor vessel and the steam generator. The reactor vessel is a pressurized chamber made of steel. Let's look at the reactor vessel more closely. You can see the reactor core here. The rods in the core store the nuclear fuel, uranium oxide. They are called the fuel rods. You can see the control rods jutting out of the core at the top. These are made of materials containing boron or cadmium. When these rods are pushed in, they absorb the neutrons and reduce the number of neutrons available for the reaction. So, these rods are used to slow down or stop the nuclear reaction. The reactor vessel also has water, which is both a coolant as well as a moderator. Moderator is a material that slows down the speed of fast-moving neutrons and prevents acceleration of nuclear reactions beyond control. The high pressure in the reactor vessel ensures that the water around it remains liquid even at a temperature beyond its boiling point. A set of pipes carrying cold water in and hot water out of the reactor core controls the temperature in the reactor core. Next to the reactor vessel, we have the steam generator. Let's zoom out a bit to view the three different pipe systems for water. The purple loop carries the superheated water that is pumped from the reactor vessel to the steam generator and back. Note that this water does not mix with the others. The blue pipe system over here is the steam line that runs from the steam generator to the turbine. Through this line, steam under high pressure flows through the turbines, spinning the turbines. The spinning turbines in turn move the generator, which uses an electromagnetic field to generate electrical energy. The transformer attached to the generator converts this electrical energy to a high voltage. The electrical grids use the high voltage to transmit electricity efficiently through the transmission lines for domestic and business needs. Now, for the last part, let's zoom back to the steam generator and turbine region. Observe that the turbine is connected to a steam condenser at the bottom. The spent steam after turning the turbines is cooled by the coolant water that is pumped from a water source such as the ocean. Steam condenses into water on cooling and collects in the condenser at the bottom. Some plants have cooling towers to eliminate excess vapors. The condensed water is then recycled by pumping it back to the steam generator to once again generate steam. And the cycle goes on. The control rooms monitor the entire working of the plant. Enormous safety precautions and wisely chosen locations can make nuclear energy as the way forward to meet world's energy needs.